The number of severe storms in city J in a year is binomial with n equals 5, p equals 0.6. Given that m storms strike city J in a year, the number of severe storms in city K in the same year is m with probability half, m plus 1 with probability a third, and m plus 2 with probability a sixth. Calculate the expected number of severe storms in city J in a year in which 5 storms strike city K. So let's understand this condition given over here. This is saying that if there are m storms in city J, then there will be either m in city K or m plus 1 in city K or m plus 2 in city K. It means that the storms in city K will either be equal in number to those in J, like m and m, or there will be one more storm in city K, m plus 1 and m, or there will be two more storms in city K, m plus m and m plus 2. So which means that if we are given that there are 5 storms in city K, then the storms in city J are going to be 5 or 4 or 3, because as we just said, the storms in city J are either equal in number to those in K, or one less or two less, because if K is 1 or 2 more, then it means J is 1 or 2 less. So 5 storms in city K, according to the given condition, imply that there are 5 in J or 4 or 3 in J. So J has 3, 4, or 5. So we need expected value of J storms given K equals 5. So we let J be the storms in city J, K in city K. So we need expected value of J given K equals 5. And these are italicized. So the corresponding italic letter indicates the storm in that city, number of storms in that city. So to find this expected value, we first work our way towards finding the corresponding probability function, which will be this one. Probability J equals J given K equals 5. That's the probability function for this expected value. And this is equal to probability J equals J and K equals 5 divided by probability K equals 5. So we work our way towards finding these quantities. And that's what we're doing in this table. So J given K equals 5, as we just discussed, J is going to be either 3 or 4 or 5 if K is 5. And the probability of 3 means that the difference between them is 2, which is going to be this situation. That's where the difference is 2 between this and this. So the probability of that is 1/6. The difference of 1 will be probability 1/3, and equal will be probability 1/2. So 1/6 difference of 2, 1/3 difference of 1, and equal probability 1/2. And we are given that the number of storms in city J is binomial with with n equals 5 and p equals 0.6. That was given in the first statement, first sentence of the problem. N equals 5, p equals 0.6. So that means f of j is 5cj, 0.6 power j, 0.4 power 5 minus j. And when j is 3, it will be 5c3, 0.6 power 3, 0.4 power 5 minus 3, which is this entry. And similarly, this for j equals 4 and j equals 5. So remember, the expression we are looking for has numerator probability j equals j and k equals 5. So let's call these probabilities as little p. So the way we read this, or one way to understand this, is that So this is the entry when j equals 3 and k equals 5. So we are saying that probability 3 storms in city J and 5 storms in city K. So that will happen, first of all, if the difference between them is 2. And we just said that for them having to have a difference of 2 is 1/6. So the difference should be 2, and there should be 3 storms in city J. Yeah. So this is what J equals J, J equals 3 and K equals 5 means, that the difference is 2 and there are 3 storms of city J. So the difference of 2 has this probability and 3 storms in city J has this probability. So that's why this probability is obtained by multiplying this column with this column. So 1/6 times 0.3456 gives us 0.0576, and similarly the other two. J equals 4 and K equals 5 will be this times this, and J equals 5 and K equals 5 will be this times this times this, equals that. And then in the denominator here, we need probability K equals 5. So K equals 5 can occur if J equals 3 or J equals 4 or J equals 5. And the probability of that happening is this or this or this. Yeah, K equals 5 can happen with J equals 3, which is this, or with J equals 4, which is this, or with K equals, or with J equals 5, which is this. And therefore, these are the only situations in which K could be 5. So this or this or this, and therefore, to get K equals 5, you add up these situations and you get that. And therefore, this main probability that we are looking for, J equals J given K equals 5, that's obtained by dividing this column by the total, by the corresponding total. So this entry is 0.0576 over 0.18288. And similarly, this one is this over that, and this one is this over that. So now we are all set to calculate the expected value of J given K equals 5. So that will be J given K equals 5 times the corresponding probability of it. So J given K equals 5 could be 3 or 4 or 5. So when it's 3, the probability is 0.315. So 3 times 0.315 plus 4 times 0.472 plus 5 times 0.213. That's 3.9. That was choice C.